Hey, how you doing? Welcome to my latest video. My name is Angela McCall. I am a multidisciplinary digital creative, which is a very fancy way of saying that over the 3 decades that I have been working in industry, there isn't much that I haven't encountered, learnt how to do or digitally create, from programming to video editing to graphic design, branding and building and playing with mobile apps. But I started out as a website developer, and in this video we're going to talk about version control systems. Now, if you're familiar with my channel, you will know that I have done other videos on this topic in the past, but as I now find myself moving from industry into the education sector and becoming a dual professional with basically an expert in 2 different industries, I've realized that most of the UK pathways that we teach to 16 sort of 19-year-olds in post-16 education doesn't actually include version control systems or the knowledge of them, which is a real shame, because our industry here and probably globally now actually requires most people to have a working skill of version control systems, predominantly Git and GitHub. So in this video, I am going to be teaching you as if you've never even heard the term version control systems. So the start of the video will give you a very quick backstory as to why we use the actual tools Git and GitHub, because there are many others that we could be using. We're going to look at why version control systems exist to begin with, and then we're going to look at what it means to look at your local repository before we connect to a cloud service, which is GitHub, and connect up there and then start working in a team. So we're going to take you through from 0 to, let's say, at least 80% of the way through the knowledge that you're going to need to enter the industry. So if you haven't been here before on my channel, please be really sweet, give me a subscribe. I'm going to be doing a lot more content now that is supporting the 16 to 19-year-old environment of college students and young professionals looking to enter the industry, as I now transition from industry professional into an educator professional. So let's get started. So the first step that we're going to look at is version control systems, and that does mean I am going to have to talk at you for a moment or two just to get you this concept in your mind. But the good thing is this video is time stamped, so you can speed through this in the future. But if it's the first time that you're watching this video, I ask you to listen to what I'm about to teach you, because without this knowledge it makes the rest of your learning curve a lot steeper. So version control systems. There'll be times in your life so far that you've had to write a really important document. So it could have been an essay, it could have been a job application for an apprenticeship, it could be that you are looking to go to a university and you have to write a statement about who you are. And with that importance comes the pressure of getting it perfect. So you might find yourself writing this document and not liking the first version. So you put it to one side, you save it as V1, and then you maybe create a second document. And actually, during the course of this process of writing this one document and being one person, we've probably wrote 3 or 4 versions. So you could have about 5, 6, 7 or different 8 factors involved in this just one little task in creating this one perfected document. Now, as one person being involved in that project, that's fine, that's easy. You can retain all of that information in your head, and you can track what is the latest version and which bits of those versions you liked and what you didn't like. But when you start working on other projects like a small website or a small software application, lots more factors become part of that process. So for example, a 4-page website will have different videos, different images, different assets, you'll have different fonts, there's the copy that goes on the actual pages themselves, and you might even find yourself creating 2 or 3 different versions of pages, especially as a newbie developer while you're still playing with your skills and learning how to lay things out and so on. So actually, even a 4-page website could have maybe upwards of about 20 to 25 different factors and assets that you have to involve and control and keep your mind on point as to what is the latest version of whatever it is that you've been developing. And although you can do that as one person because it's such a small project, you start to realize that actually you need a little bit of a system or a method to control your environment. And this is how we used to work as developers back in the day before version control systems came into play. Now let's take it another step and say actually you've got to work with a college mate of yours or a student or a team member in the industry, and now you've got to share files. But when you've shared a file with them, maybe you've sent it as an attachment on email or uploaded it to like OneDrive or Dropbox and they've downloaded it, you can't track what changes they're making to your code. Okay, and that's a little bit scary. You've got to kind of trust the process. And they also might then make 2 or 3 different versions of your code. And then somehow they've got to remember what they've done so that they can get the latest copy and merge it back into your project. And now we've got quite a lot of factors happening here. We've got 2 different people working independently with different versions. And the whole thing is starting to come a little bit more stressful. And let's now just take it one more step even more. And think of a platform like Amazon. Without version control systems, the likes of Amazon, the beast that it is, would not exist today because there are far too many. There are literally thousands of working factors. They'll have teams of front-end developers, back-end developers, database managers, content creators, user account controllers, and that's before we get into the whole thousands of products, or I should say millions of products, and all the descriptions that they have, and how many things that they're uploading and unloading on a daily basis, and all the different financial transactions. Now, there is no way a platform that size, given the fact that I think they actually have about 7 platforms, because they have an Australasia one, a Canadian one, an American one, and a South African one, or whatever, and they all have to work very similarly, because when people travel around the world, they'll expect that same professional environment on whatever platform they then happen to be working on within Amazon's world, as it were. So with those many factors and people leaving the work and contractors coming in for short periods of time, you have to be able to track what happens to every single asset, how it's developed, what has happened to it in its history, as well as how it's merged into the main project, and how there are different milestones being met, different parts of the site being published and deployed live for users to be using it, and be able to track back what happened last November when you developed something that now has a bug in it. So without a version control system, there would be utter chaos, and platforms like Amazon just wouldn't exist. So now we have an idea of what version control systems are. We understand there could be lots of different versions of the same file. We understand we need a way of controlling our environment and a system in place to track everything that's going on. So that's where the terminology version control systems come from. So now let's take it and quickly understand why we are using Git and GitHub in industry as like the #1 tools to use, because there are lots of tools out there that offer version control system solutions, okay? Okay, so now that we have an idea of what version control systems are all about, let's roll back in time to 2005. And in 2005, this is the kind of technology a developer would be working on, whether it be in the office or at home on their own sort of computer, as it were. And this was state of the art. Now, in the UK here, we had, obviously we was rolling out broadband through the world or through our country, but it was still very unreliable in the sense that there would be periods of time during the day where it would fluctuate, go down, or pause temporarily. It would disrupt downloads of software that we were doing. We'd have to restart over. We would have to flick back and forth between the different programs that we were working. We didn't have the luxury of working on a modern developer setup like this. Now, this is my computer system at the moment. I have 3 19-inch flat screen, high quality LED screens, and I can just turn my head if I want to look. So I actually have a process whereby my left screen is my research screen. I have my middle screen, which I'm looking at right now with you guys, running OBS, which is what happens to be on that picture. It's about 5 years old, but I have my development screen, and then on the right hand side I have my public or my test screen, and I have the luxury of just turning my head to see what's going on. But back in 2005 we had to flick the screen, so we had to battle internet connections that were unreliable and unstable. Some of the world was still working on dial-up routers and not even on broadband, and we had to flick back and forth. And just to give you one more clarity here as well, this entire monitor screen is actually smaller than the inside of that little square there. In fact, it's probably about the size of my photo being brought into OBS right now on that screen there. And that's how little space on the monitor we actually had to work with. So life was a bit challenging. So back in 2005, there was a very clever man called Linus Torvalds. I think that's how you pronounce his name. He was actually a very clever chappie. He had already launched and developed the Linux operating system. And if you notice, Linus, his name, and Linux, very similar. All he did had changed the last letter from S to X. He named the operating system after himself. Anyway, long story short, he was in charge of this massive global software development project called the Kernal project, largest single code based project that's pretty much ever taken place in history. By single code base, I mean that there was thousands of developers across the globe all working together on one project, okay, one set of files. And so they had to use a system to kind of manage things. Now, back in 2005, very early versions of version control systems were around. There were 3 or 4, and the best one of the best at that time was a tool called BitKeeper. And all of these thousands of developers that Linus had working across the globe in different time zones, in different countries, whose mother tongue would have been a different language to their co-workers in another country, were all working together across these challenges using a very simple tool called BitKeeper. Now, obviously, BitKeeper was the best option that they had available at that time, but it was still limited. It was never really designed to enable these developers to work at this kind of intensity. So there was challenges with it. And then overnight, BitKeeper decided to revoke its open source free license because it suddenly thought, oh, hang on a second, we've got thousands of really experienced developers using our software for free. What we'll do is we'll charge them for it. Now, for Linus, this caused a huge headache. Overnight, he had a global army of senior developers and really experienced professionals going, I can't access my files, or this isn't working and I can't do this. And he had people left, right and centre coming at him going, the project's in turmoil, we can't operate, we can't do this, we can't do that. So Linus had to get them back up and working really quickly, and he had 3 choices. 1, pay the license fee, but what would happen a few months later if they changed the fee and put it up again? And we aren't talking just a couple of 100 people here, we're talking thousands of developers, so it would have been very, very expensive for him. 2, use another company's software, but then already they were on BitKeeper and that was the best of the best and they were struggling with it. Or 3, create his own. And that's what he chose to do. Now, bearing in mind that this project has come to a complete standstill and everybody is stressed out because they can't work, Linus didn't have the luxury of taking the next year to develop all these lovely systems with beautiful logos and wonderful website interfaces. He needed this team up, running and working like yesterday. So in less than a month, pretty much single-handedly, he developed his own version control system and he had to give it a name, and he chose to give the name Git. Now, we've already discovered that he's a bit of a quirky personality, naming the Linux operating system after himself. So Git was a bit of a tongue-in-cheek name. In the UK, we have that as a slang word, which we call people that are a bit foolish, a little bit naughty, or a little bit of a pain in the bottom to us, shall we say. And you could say it was a way of giving 2 fingers up at BitKeeper for being a bit of a git to him to pull the license to begin with. But it was also used as a word because it had no other meaning in the IT industry, so it wasn't going to be like it was going to get confused. Its interpretation was never going to be misunderstood for meaning something else because it wasn't a word related to IT in any way, shape or form. And the beauty of it, just 3 letters. So it's extremely fast to type. And that was important because if we go back to our lovely computer of 2005, one of the things that Linus really needed this Git version control system to do is, whilst they're busy developing and they're writing their code, they don't want to switch to another software program. They need to fire off a command line straight to the operating system and fire off that command straight away to take a snapshot of their project in that precise moment, like a photo. And so it had to be a command line driven thing where you didn't switch programs, you just write 5-6 words max and whatever you wanted the computer program to do with regards to your project, it would do it. So this is how Git became the industry #1 leading version control software pretty much overnight. You think he's rolled this out now to an established team of very qualified, experienced, influential developers in their own communities all around the world, and they've obviously then spoken to their teams, and their teams have adopted it, and within a very, very tiny space of time, it dominated the developer market and community as being the #1 version control system to use. And even today, I don't know the full stats, but if I was to hazard a guess, I would say something like 80 to 85% of the developer community still use Git today as the #1 tool to use. So now let's imagine Git's been used in the industry now for 2 or 3 years, okay? During that time from 2007 to about 2008, tools, cloud-based solutions like OneDrive and Dropbox were starting to emerge. They didn't exist in 2005, but by 2008 they did. And although you could say the developer community could have embraced those as cloud-based solutions, they still wouldn't have allowed people to track changes and things that were happening. So noticing this problem, but knowing that the infrastructure in the world was going to these kind of cloud-based solutions, by about 2008, 3 or 4 other really, really clever developers who had fully embraced Git thought, you know what, we've still got that one challenge of how we share and track files with our teammates and co-workers, whether they're on the computer sat next to us or on the other side of the planet. It would be really good if we could somehow extend Git and this really powerful version control system that Linus had, designed and launched, but we could embrace the cloud technologies that are emerging as well. And what they did is they created a separate company. So Git and GitHub are 2 different things. They created GitHub and made the first sort of software as a solution type of cloud-based platform available that plugged into Git. And so now the 2 of these tools kind of work in synergy with one another, and so GitHub was launched. And of course there are many other tools, version control systems and cloud-based solutions that exist. GitHub happens to be the first that came out in the industry, and it's the one that most people will recognize and expect you to be able to use. So the rest of today's lesson in this video is all about Git and GitHub being a unified tool that works as your version control system for managing your projects, whether it's on your own as a solo developer, which is pretty much how I've always ended up working, or if you end up working in a team environment, which most of you will do when you go out into industry, you'll walk into environments where there are established teams with established clients, with established software projects or websites, and you'll need to slide right on in to an established working environment. And knowing how to use version control systems, Git and GitHub, will give you a lot of power to not only boast on your CVs or your resumes, but also you'll be able to talk the talk, walk the walk, and be able to slide in without too much strain and stress. And if you're in this industry right now, and that's where you're finding that you're like, oh, I don't really have enough knowledge on version control systems, this is one of those reasons why this sort of complete starter guide video now exists. So let's move on to step 3. Step 3 is understanding our local repository environment. So what does that mean? This is now a working example of how Git will work as a version control system on your own computer. Remember, this had to work offline because the internet connections were unstable and it was causing disruption to people when they were coding. And when the internet was stable, they could then upload and share files and do what they wanted. So the whole concept was, not only did it have to be fast and command line driven, it had to be something that they could do on their own computer. Okay, and on the left hand side in the green is everything in this green area that is taking place just on this computer. No internet connection. You could be working on a laptop in the middle of a field with no Wi-Fi connection whatsoever, and you could still 100% perform as a developer. So we are going to learn about 3 different things to do with our local repository. And a repository is a way of saying a bank of files and folders. We are going to create a working directory. We are going to add files to something called the staging area, which is a bit like a waiting room. And then from there, we're going to commit these files to the history of our project, and the whole thing becomes part of what's known as our local repository on our computer. And so that you kind of have an understanding of how that fits in and what moves and what happens. This here is then a photo of how we then connect to remote. So towards the end part of this lesson, we will then take a copy of our local repository and clone it almost and push a copy of it up into the cloud where it can then live for safekeeping. And the beauty of doing that means that we can now start pulling down copies wherever we go to work. So for example, this is my current setup right now. So when I'm in college or on a client's site and I need to show them the latest version of whatever I do, I am working off of my laptop. And I can pull down from GitHub, my cloud-based repository, okay, my remote repository, a copy of the files that I was working with. But when I am at home, like right now, I'm working on my own computer, which is this setup here. This is a lot nicer to work on because I've got 3 screens instead of 1. It's a lot more powerful than my laptop. So I prefer to do about 90% of my development work on my desktop, but I need to have my laptop moving around with me when I go and do client sites or I'm working in college with my students. So I push up and pull down from the cloud my program and my code, and if I make changes in any location, I just put a copy back up in the cloud so that next time I can pull down the latest version and I haven't got to worry about USB pens or trying to track by giving them different names like version 1 and version 2 and all that jazz. Now for you guys, you might actually be having 3 different environments, because if you're a college student on a workplace like a T-level course, you might have to be doing half your time in industry, half your time in college, and then you'll be working at home. So you might be working on the computers that your boss has given you to work on whilst you're in the office. You save your files that are relevant to you up into your own repository in the cloud. You come home, you can work on them at home, and then you can push them back up, and then tomorrow you go into college and you show your tutor or your mentor or your educator like me what you've been up to, and you can pull down another copy. And that means you're always tracking, even if you're sat in college right now and then you do some updates, when you're back in the office you're still working with the most up-to-date version, and you can see your entire history over your entire project even though you've worked on 3 different machines. And each of those machines will still be running a local repository. We just need to be able to communicate with the remote hub about where we are on that journey, and without version control systems we wouldn't be able to do that very easily. So let's roll this on a little bit further and actually realize that when you're actually in industry, you might be one person working with your own local repository, but you're in a team environment with all your co-workers and colleagues. It could be your college class and you're doing a college assignment whereby, let's say you do a page each on a profile about, I don't know, the class of 2026 as it were, and you're all doing one website, all looking after your own pages, and at the end of it your tutor and you're all going to merge that into one website and publish it, for example. So this is how and why we need to understand version control systems. Okay, so now we know what it is. How do we actually use it? Well, that's where we're going to start looking now at the installation process. This part of the video, you're probably only going to need to do it once if you're working on your own computer. If you're in an office environment, the chances are they would have given you a computer to work on. The software and the tools and things that you need are already installed, so you don't need to worry about this. Or if you're in the college environment, you might need to talk to your IT professionals and the IT department first to make sure you're allowed to do this, but you might also need to work just slightly different to on your own computer because you've got a college network with firewalls and different processes and security features in place. So first things first, you need to go to the Git website itself. So all I've done is I've googled Git installation. There's the website. I'm working on a Windows computer, as most of you will be, and this is the page of information regardless of what you're doing that you could worth knowing about. Okay, first of all, it always tells you what the latest version is. So if you are working on an office computer and Git's installed, in a moment we can run a git version command and find out what version you're on. If it is an older version, you can go and ask someone, say, look, actually I think it's going to be better if I do an update here, at which point you can follow the same installation process as if you was installing for the first time, because it will take away the old version and install the new version as part of the process. So if you are looking to install your Git onto your computer for the first time, chances are you're going to be running a 64-bit computer. Click on this and follow the instructions like you would normally. If you are working in a college environment, you are going to possibly have to work inside something called a Winget tool. Okay, now just think, when you download software onto the computer, it installs it. Well, you are doing that, but you're kind of like in a little bubble. You don't need to worry too much about why and what it happens to be. But if you do look at this screen, I want you to pay close attention, okay, because everything that you do is going to be case sensitive. So there are a capital G here on these middle two words, okay? The dashes are important. There is a single dash there, and then there are double dashes. There are spaces between the words, and there are only the two capital letters. So make sure you type this entire line exactly as it is shown. Now, where do you type it? So what you need to do is, on the bottom of your computer environment, you will have the ability to search. So I want you to type Windows PowerShell, and as you do so, your computer will offer you different programs. It will eventually offer you Windows PowerShell, and I want you to open it. And when you open it, you're going to see a screen like this, and in that screen you will copy and paste that command, and you will paste it. So I'm going to copy, and I am going to open and then I paste it. Now, I'm not going to run it because I'm not on a college network filming this. I'm actually on my own home computer, and I don't want to upset my own working environment or confuse my own configuration. But that's how you would get going. After a few minutes, it will think about things, and then you'll eventually get a successful installation message like that shown down here in the red arrow. And once you get to that point, you can close that window, and we will all be from the same point moving forward in this video. So we are going to be looking at configuring the version control systems for a project. So there's a few things that we need to do. From this point forth, we are going to be working on Visual Studio. Now, if you are a college student like ours, we often start our students off using the text editor Sublime because it's a lot less daunting, a lot less buttons and gadgets and things to click on, and is a lot more simpler to get your head around as extreme newbies developing and learning to write HTML code, for example, or CSS code. When we are in industry or a solo developer environment, 99% of us will be using something like Visual Studio Code. So from here on in, everything that I am going to discuss, show and demonstrate will be using Visual Studio. Before we do any of this, we do actually need to, first of all, just help ourselves out a little bit by creating a folder for our project. So I'm going to come out here, and this is all part of the configuration process. Obviously, if you're coming back to a project that already exists, the folder would already exist. So I'm going to call this my root, and you can see below me somewhere that I've got an example already going where I've played to do this course. I'm going to call this V1 purely because I don't want to get my computer confused with my test run earlier on before I made this video. So I'm going to hit return. So my own root folder is called root-VCS V1. You call yours whatever you want, okay? Root VCS is what I've done in most of my walkthrough documentation that supports this video. Whatever you do from this point on, this folder is the most important folder in your project, okay? I'm going to close this screen because we don't need it anymore. Okay, so we're going to open the terminal window, but this time we're going to do so from within Visual Studio. Now, because I'm trying to make it easier for you guys to see, all I do is I work at a kind of a really zoomed in version, and as I zoom in, my menu starts to hide inside this little I was going to say hamburger menu, but it's not, like this little shortcut. And there's my terminal window. So it's still there. Yours was probably going to look more like this. Do not panic if it's slightly different. I'm just blowing my window up to make it easier for you guys to see. So I'm going to open a new terminal window. And at the bottom of the screen, ignore any messages. You can clear them. Make it nice and easy. Already had one open, but that's fine. What we've got here is now that Windows PowerShell. So exactly the same thing. It's just I'm opening it inside Visual Studio, as instead of having a separate screen that I have to flick back and forth to. Now, I don't have any folders open. I don't have any project open. So it's like, okay, well, I'm going to just stick you here. And this here is called your prompt. And this is the path of where you are looking at the moment. So just in case, one other thing that I want to show you, if you're on a Linux operating system, it might help you to learn this. If you are struggling on a college computer with PowerShell and it just seems to not be working, you can open and run Git Bash. Git Bash, as you can see now, this window is open. Okay, and I've selected and it looks slightly different. Is exactly the same thing, it's just it's a terminal window provided by Git itself, as opposed to Windows, the operating system on your computer, providing the PowerShell window. You choose whichever one you want to work in. 99.9% of the time, the commands that you use will be identical, okay? I'm just going to close Git Bash. I've been used to using PowerShell, so that's where I'm going to stick my environment. Now I'm going to close this window for a moment, okay? Because what I want you to do is now focus on the left-hand side of my screen. As I move my mouse up to the top, there's like, it looks like a little bit of a stack of paper folded over, and I'm going to click on it, and as you can see, it's going to open my Explorer window, and that is like using and operating Windows Explorer. That is this version in one place. So again, we don't have to have two different things open on our computer. So in here, I'm going to open my folder, and I'm now going to explore to my documents where I stored my folder. Okay, you put your folder wherever you put it, so you need to surf now to that location, select it, and then at the bottom it will say select folder, and the screen's going to change. And as you look, if it opens a chat window, just close it. But if you look, I have now got that folder showing in my Windows Explorer. Now it's empty, there is nothing, we haven't created anything yet, so the whole of this screen is blank, which is perfectly fine. I'm now going to reopen my terminal window, and now if I clear the screen, it's showing me that because this folder is open, that's where I need to be. It understands that, and now it's opened the terminal and put me at that location, saving me a lot of work. Before you do anything using Git, you always need to make sure that this location, this path, represents the folder for the root of your project. Now, when we talk about website design, which is where most of my students are from, so I'm going to use that as an example in this video, but it could well be your software project, you are using a root folder. That's the terminology most of us will use and we are already familiar with. And that is perfectly fine. But we need to make that root folder also become the working directory for our version control system to manage. So there's a few things that we need to do. First of all, let's just learn the command to see which version of Git we are using. So this terminal window can do jobs for all different types of programs. For example, I do split mine often, and I run two windows, and in my second window I will often have PHP running for my server. And when you get really into being the developer, you might end up with 2 or 3 terminal windows open, okay? I just wanted to show you that was a possibility. But because of that, we don't want to confuse our computer as to what tool we are working with. So we always start our commands with the word Git, okay? So we're saying basically we're going to use the tool Git in this command. And then I'm going to put a double dash and I'm going to write the word version. And it tells me I'm on Windows, and it tells me the version number. And as you can see, for those that were vigilant, my version is the same version that Git is reporting on their website as being the latest version. So I'm all good. So I'm going to clear my screen. Okay. Second little cheat in life. We're lazy, us developers. We don't always want to be writing the same thing. So we can push the up arrow on our keyboard at any time and it will scroll through the commands that we've just recently written. And you don't have to write them all again. Okay. And it's quite quick that way to operate. So now I know I've got the correct version. The next thing I'm going to do is I'm going to create that folder to be my working directory. So remember here that this is my working directory. I said we start off with a working directory. Well, at the moment, Git is installed on our computer, but it doesn't know, out of all the hundreds of folders, hundreds of projects, whether it's programming projects or coursework or whatever, it doesn't know which folder to look at. So we have to tell Git, oi mate, look at this folder. And we do that through a process called initialization. Now, initialization is quite a horrible word to type and spell. And in the UK, we spell it with an S. Americans and other parts of the world spell it with a Z. So to remove the confusion, we're going to start by telling Git a command, and we're going to init, just 4 letters. Okay, the very first time you ever run it, it will say it's initialized an empty repository, which is perfectly fine. And it tells us where that repository is, which we know is the correct location. And it tells us it's now installed a Git folder. Okay, now if I go out to my actual documents and I find that folder, I can see at the moment that Git folder existing. And the reason I can see it at the moment on my computer is because of my view menu. I have turned on file name extensions and hidden items because I like to know what I'm working with at all times. If I was to uncheck hidden items, my folder disappears. That doesn't mean to say it doesn't exist anymore. It's just not visually being reported to us through Windows Explorer. And your college environments might be showing you a system like this. So I need to give you another way that could be locked out and you might not be able to show hidden files or items. On your own home computers, you'll be fine. Maybe on your office environment, you'll be fine because they're used to being developers and that's what they'll probably be working with. But on a college environment, don't forget, they lock a lot of things down. So if you go to your folder and you cannot see it, I'm going to show you a second way to check. So let me close that. What we can do here now, this is a regular terminal, so it's nothing to do with Git. This is a regular skill to learn. But we can type directory with a dash, capital F for Freddy, and we're going to type the word force. And what's going to happen is now our terminal is reporting to us everything that exists inside that folder, at which point it's telling me another folder exists called Git. And that is a way that you can double check. So if you're in a college environment and you cannot show hidden items, this is your backup route to being able to understand that that folder exists. Git knows our folder has now become our working directory. So just that one action has turned it into a initialized folder, and now we have a working directory. So we're on this first marker here, okay? But Git does not know who we are as individuals, and Git needs that information so that when we start to work with teams, it can track person A from person B's work and person C and so on and so on and so on. So we still have a few things that we need to do. Okay, so what we need to do is we now need to tell Git who we are working with it in this project. So if you're following in on my documentation, there are 2 different ways to do it. So this bit here tells us how to do it. Now, if you look at the top, we've got a personal computer that we can create this as a command once and then forget that it is existing. This is how I operate on my computer because I'm the only one that ever uses my computer, whether it be my laptop or my desktop. But if you're on a college network, that will change, and as soon as your lesson finishes, you go off to lunch and another student after lesson will be using that room and that resource. So you need to do this every time you create a new project, and you need to just double check what's going on. So the only difference between these 2 commands is the top one has a global flag. Now we will learn about flags in just a moment, but a flag exists to change how the command functions or performs. So we are going to tell Git that we want to configure something. If you're on your personal computer, you can do this command once by using the global flag. And if you're on your own computer, you ignore that it exists. But we are configuring the username, and we put our name in double quotes. This is really important to understand for all you students out there who always put spaces in your folders or your file names. This is the headache you are now causing yourself, and why your teacher has probably said to you on many a time, when you are programming, you do not use spaces. And be very vigilant about how you use capitalization and how you use underscores or dashes in your file names, because everything that you do is case sensitive and computers do not like spaces. So to get round the fact that we have Angela McCall as my name being 2 words, I am going to put double quotes around my name as a way of telling the computer this name has a space in it. Please don't panic. If you look on the line underneath it there, because my email address does not have a space, I can just write it. So I want you to do these next 2 commands. Now I'm going to repeat this process at the top here on my computer, even though I've done it, just so that I can demonstrate and walk through with you. So I'm going to say git configure. Okay, now because I'm on my own computer, I'm going to use the word global. Username to be Angela McCall. Okay, so I am just going to run out of space, so I'm just going to make my screen a little bit smaller. There we go. All right, if you're on your college computer, don't use that bit that I've highlighted, and I'm going to hit return. Okay, now I'm going to say git config, but this time instead of my username, I've pushed the up arrow and I'm just going to backspace and then put email to make it quicker, and then I can put my email address. So I would put like McCall at, and then whatever it is. Okay, so you do the same thing there. Okay, so we've now put our names into Git and we've put our email addresses into Git. But how can we check? Because if we've come back to this computer and it's been shared use by other students, they might have put their name in. So we just need to double check we are the right person. So we can just type that same command without the actual explicit details. So user.name, nothing else, and it's going to report back to me that I am the user, Angela McCall. And of course, if I see a different student's name, I'd have to repeat that process. And you do the same thing for your email address, and that's how you can quickly check you are the right person on your computer. And when you're happy with everything and you want to get going, before we get actually onto using the tool itself, we're just finishing now the configuration process. The last command that we can learn is git status, and it will just tell us where we're at. And at the moment, I'm lucky because I've already set this up on my computer. I'm on the main branch of my computer. There's nothing to commit. Everything is funky-dory. So I have nothing to worry about at this moment in time. Okay, if you have got the word master, this is what you need to do. Now, master is a politically incorrect word. A lot of people sort of associate it with the slave industry, and we're modern people. We don't work in those terminologies anymore. And so if you do find yourself working on a project or a folder and it's using the main branch as master branch instead, exactly the same thing, you're just going to need to change the name. So how do you do that? Okay, so we are going to give git a command. Okay, and we are going to configure something to do with a branch. And we're going to move, so -m, that's what that flag means. And we're going to move it from master to main. Now you would type this, but because I'm already on main, I'm going to switch once and then switch again just to show you how it changes. So the one that you are on, you put first, and then you switch to master. Okay, so obviously now if I do a git status, I should be in the same situation as you guys. I don't want to be calling my main branch master branch. I want to call it main branch. I'm going to repeat that exact same process, but instead of calling it master, we're going to say I want to switch from master to main. Okay, and now if I do a git status, okay, you can see I'm back where I should be. So I've just shown you there by swapping a couple of times. And as a quick side note, if you are working on your own computer, you do not want to be fluffing around all the time. You create a new repository and call the branch main. You want to be able to just set it once and for all, and this command here on the screen on my documentation shows us how to. So we can do a git config. Obviously it's going to be a global command. We are initiating the default branch to always be called main. So I'm just going to do that right now by copying that code there and putting it into my window. So I am going to clear my screen to make it easier for you guys to see. So we're going to write git config. Okay, it's a global command. Okay, we are going to do something with the initialization process as the default branch. Okay, and then if you go back to the documentation, just to remind myself, we're just going to call it main. Do pay attention to the fact that there is a capital B there. That is intended and not a typo mistake. So default branch main. Okay, so all I've got to do is type main now and hit, and forevermore my computer will now be using the name main for every project that I initialize. Okay, so if you need to watch this video in the future, this is the moment that you probably are going to want to watch the video from. Okay, so at this moment in time, we have learned what a version control system is all about. Okay, we have then learned specifically about why Git and GitHub are the industry standards used by all the developers mostly around the world. We have then looked at what very quickly a local repository is, where I have shown you that green diagram of a local computer with the three areas, which is working directory, staging, and then the repo itself. And that is the meaty bit that we're now going to be concentrating on for the majority of this video. We have also then looked at how we install it on our computers, whether that be on a shared network, college environment, or our own computer system. And last of all, we've got to a point where we have configured virtual control system, or Git, to work with a specific project. By that, we have initialized the folder to become our working directory. We have told Git who we are, and we have always set the branch, the main default branch of our entire project, to be called main. Okay, so we're in a really sweet spot to start now using the tool itself. So in order to do that, we are going to look over at my left-hand side monitor, okay, and what we're going to need to do is add some files, but we can't add any files. We've not created any yet. So for the next 5 minutes, what we're going to do is we're going to quickly work our way through a process of adding files to the staging area and then adding them to the history books of our project. So we are going to go File, New File. I am going to call this Index because I'm going to build a mini website page, because that's probably the most familiar that you guys are going to have. I want to store it in, check the folder location, that's good. Okay, and there you can see it has now opened me an indexed HTML file ready for me to start writing, and you can see it appearing in my Explorer window. Because I'm a cheater, I'm going to use the exclamation shortcut to insert some HTML template there. This is my index page, and I'm just going to, just so that we've got a little bit of something on the screen to see, I am just going to accept the AI code that's coming up right now, and I've put a H1 tag and a P tag, just so that we have something on our screen, okay? So in Sublime, you would have right-clicked anywhere now and opened in browser. You can't do that in Visual Studio. Instead, you have to kind of do it a slightly different way. So I've moved my mouse over to the right-hand side, right-clicking where it says Reveal in File Explorer, and it's going to show me my file, and I can just double-click on it now, and it will open in the browser window. So there is my H1 heading, and I know my page is working nicely. Now I have a file. I want to add this to my project. So here I am in my working directory. I now have one file existing. So let's add it to my, as a snapshot in history of this precise moment in time. So I am going to click on Git, because we're going to give Git a command, the word add, because we're going to add the file. And I know this file as being the index.html file. Okay. Doesn't look like anything has happened, but if I do a git status now, okay, it's going to show me that I have a new file, because it's in green with no commits made, but there are changes. So Git is basically telling me it knows my file exists, and I have added it to the waiting room, so it's in this staging area in case I want to add more files to this little snapshot in history? Well, I don't have any other files at the moment, so I'm going to go straight ahead now and commit it to history. So coming back to Visual Studio, okay, down here, I'm now going to do git commit because we're committing it to history. Now, every time you do a history save, you need to use a little message to tell yourself, your future person, why you made this commitment to the history log. Okay, so I'm using the little flag called -m, and I'm going to put this as my first commit, and I'm going to call it my index page. Okay, just so that I know what's going on, and I'm going to hit return. And now what is happening, let me just make this larger for you. Okay, I am told that one file has changed, okay, and it's telling me the code, the ID number for this commit action, which is really important later on in the video, and everything seems to be fine. If I do a quick status update now, it's saying I'm still on the main branch, which is really good. Nothing is committed, or nothing to commit because I've done it, and so my working tree is clean. Now, don't get bombarded at the moment with regards to what that means, but your working tree clean is a really good sign to sort of have that green light and go, yep, I can start working again. So this time, let's go back, and now over here, I'm going to copy this file because I'm lazy, okay, and I'm going to paste it in there, and I'm going to call it my about page, okay, which means I need to just come in here and change the title to about, and I'm going to delete this because this isn't relevant now. And as you can see, because I've got AI installed on my Visual Studio, it's trying to suggest things. So I'm just going to, just for simplicity, accept that. Okay, there's my little dot to say the file needs the regular save. So I've done that. Okay, and if we come back down now to my terminal window, I can do git. Oh, I put the cursor there, git status. And what's going to happen is Git is going to tell me, I know this file exists, but you've not told me to track it, so I don't know what to do with it. So it's like, oi mate, I know this exists, but you know, I'm not looking after it for you. So you need to add it to my to my knowledge, okay? So that's what staging does. It adds a file to Git's knowledge, okay? So I'm going to say git add, and again, because I know the file name, I can type git file. Oh, it helps if I type it right. .html and hit return. And now if I do that git status again, you can see that the file's gone green because Git now knows about the file. So we're going to do git commit -m for a message. I'm going to open my quotes. I'm going to write second commit. You don't normally have to number them like this. I'm just trying to do it to show you about page. So it's like saying I've added the about page, okay? And now it's telling me one file has changed. Now, I'm going to show you. Let's go through that process again. So git add, where's it gone? Git add about HTML, and then let's add that commit. Now let's say, for example, I forget to put the second double quote, or I forget to do the one at the beginning, and I hit return. Can you see that little prompt? Let's make the screen bigger, okay? All that has happened is Git is now waiting for me to finish that because it knows the message has to have an opening and a closing double quote. So if I do a double quote, it's going to commit the message and finish the command. If I don't want it to finish the command, I can do a Control-C, like a copy command, and it will just forget everything exists and sends me back to the prompt. I just thought I'd throw that in there as a little help to you guys. Okay, so if I do a git status now, I'm on main branch, everything is to commit. So what happens, okay, so this is all good, but we're only adding one file at a time. Now let's say, for example, we create the about page or another page in our site. That's one page, the HTML file, and we add an image, which is a JPEG file, and we add some CSS, which is in a CSS file, and all three things live in different locations. So we've got an image living in the images folder, we've got the CSS living in the CSS folder, and we've got the HTML. So they're all in different parts of the project, in different folders. How can we add them all or the whole project to the memory banks of the history log? We can do another command. So we've only got two files here, but we can also do git add -- all. So what this command does is it adds our entire project, every file, every folder existing underneath that root directory. Now this might seem like a good thing, and there is times that we need to use it, and I'm going to use it now, but that's because I'm at the start of my project. So I want like a snapshot of everything right at the beginning. If I hit a nice milestone, so let's say I develop 4 pages of my website and my client says to me, yes, I love the 4 pages, put the site live. We're hitting a milestone because we're ready to make the site a published thing. So I would then do a full commit of my entire project by doing the git add all command again at that moment in time, saying milestone hit, site published 4 pages. If the client then goes to me, oh, can we just add in a 5th page? I wouldn't do a git add all then, because the whole purpose of doing a version control system is to control what changes. So whether that's a file being added so it's new, or a file that has had its code changed, okay, then we want to track that. And the reason we want to track just that is if there is a problem with something in the future and we need to go back in time and investigate, which you will do, you will go time travel in this video before we are through. But if we have to go back in time to last Wednesday when we were developing something and we hit that nice little sweet spot and we designed a form and it was all perfect, and then since then we've broken the form, we want to just look at the files that were affecting that form. Okay, so we only ever generally save the files that we need to save. Now, we can use the git add all, which I can, and it will work fine. So in exactly the same way, you git add everything to all. So if you look at the older picture here, everything in our entire project, because we've added all of it, is in the staging. So just think of this now as the waiting room for a doctor's. Normally, you only go to see the doctor on your own because you're the only thing that's changed. You've now got an illness, for example, or you're going for a checkup. So the doctor will only generally write about you in the history log, okay? But when you do a git add all, it's like taking you, your family, your aunt, your uncle, your mother, your brother, your sister, your grandparents, the family dog, the neighbours next door, everybody that you know to the waiting room, and you're all going to have an entry in the history log when actually it's only you that has chickenpox. Okay, so the doctor doesn't want to know about everybody all the time, but unfortunately the metaphor breaks down on those 1 or 2 scenarios when you do need to tell Git about the entire project in one go. So when we're in the staging area, the purpose of it is that we only add the files to the staging area that have changed or that are new since our last commit. Okay, so what that means is when we go back to our Visual Studio, okay, obviously when we do a git add all, we basically have to finish the process by saying git commit message, and I'm going to put adding all files to history milestone hit or something like that, so I know what's going on. And then it obviously we've only changed to 1 file, so it's just showing me there that everything is added to the history book status. Okay, so for speed, I have just quickly populated my services page. So I've quickly added it, I've given it a name, I've linked in the external style sheet, which lives in its own CSS folder. I've also added in a picture called Lady, okay, and that lives inside the images folder. So I've got 1 HTML file, 1 PNG file, a new folder, a CSS file, and a second folder. So that's 5 different things that have now changed within this project. So if I was to run a git status, okay, it's going to tell me there are files and folders that have to be added. Now it's not naming every file inside those folders because it knows that the folder themselves are new as well, okay? But I don't want to be going git add services.html, git add lady.png, git add style.css. That's a blooming waste of time and energy, because the only things that I want the git commit to history to remember is those 3 things that have changed. So this time I'm going to do git add and a full stop, like a period, okay, and I hit return. Okay, again, doesn't look like anything's changed, but if I do a git status, it will tell me now that it's adding, and there you can see that it was looking at the folders, but now it's telling me that the files are also included. So I'm going to say git commit message, services page and assets created. Okay, so it's now telling me what has happened. So I now know this here is the ID for the commit that we've just made to the history books. 3 files have actually been added. 30 insertions, which is something like, I don't know, the folders, counting all the different lines of code. And it is now telling me everything has been created and it's now tracking. So again, if I do a git status now, I'm on my working tree, everything is nice and clean. We have got to a point where we have gone through our process and we are here right now. On this, we are actually up here. So we moved those files when we've added them, and then we wrote the git command, and we are now in the repository. So that is the moment that Git has gone, okay, I'm taking a snapshot of just those files and I've added them to history. Okay, so now if we come back to our project and we think to ourselves, okay, so what happens if we want to go back to like half an hour ago when I'd only made the index page? Now, obviously, half an hour, not a lot would have changed in my project, but if I was going back to something I did 3 months ago, there could be a whole bunch of changes that have taken place. So what I need to do is I need to go back in time, have a look around at what I was doing for whatever reason, and then come back to the present. Okay, we are literally talking about time travel right now. Okay, so how do we actually do that? Well, the first thing that we need to do is we need to learn how to run a report on all the different log histories and commits that we've made. So let me clear my screen. Okay, what we're going to do is we're going to go git log. Now, these yellow lines are the ID for Git's own knowledge of knowing what commit we have just made. There is our message. That's the reason why we need to put our name in here and our email address so that it knows who we are. And then it tells us whatever our message was, okay? And it tells us the time and date so we can go and track back through life. But let's face it, that ID number is not particularly human friendly. So bear that in mind because I'm going to show you something else in a moment. There's also 2 other things happening on this screen. At the top here, it is telling us that the head of its focus, so Git's focus, its head is looking at the main branch, at the latest commit that we have done. And down the bottom here, we're on a colon, meaning that we are looking at a report. We are not in any files or folders. So I can just use the Q command to quit back out. Now, what does that actually mean? Let's just think about our very first commit as being this dot on a timeline that's moving from left and right. So the beginning of the day, the end of the day, or the first day of the month, the last day of the month. Okay, time travels from left to right on this diagram. All of these black blobs are basically different commits that we make during the process, at which point Git needs to know that as we make a commit, it now looks at that commit, and then we make another one and it jumps over. And so its head is like an arrowhead, always looking at the most latest up-to-date commit on our timeline. Even though 5 or 6 others already exist, this is the one that it is focused on. Now, to time travel back in time, we need to be able to identify a commit in the past, and we need to use something called its hash commit, or it's like hash ID. Okay, now on this screen here in our code, that's what this number is, but this number is not human friendly, so we can change the way our log reports this information to us. We can do git log again, but this time we're going to use the flag. Remember, flags change how the commands operate or how they are executed. So we're going to give it a flag called oneline, and it's now showing us 4 lines of information. Those 4 lines of information are exactly the same as above, except they have not got the name of the person, the time and the date, and they have shortened the code. So if we look here, so this last one on the screen, 1A4AC9, is actually the first 7 digits shown down here. And 7 digits are a lot easier for us to remember than all of these long serial numbers, okay? So it's just like a shorthand version. And there is our message so that we can quickly read up this whole line and see where we're at and what we're doing. And remember, the most newest commit that we've done, okay, and obviously I've done a few while I was testing this process out, but the most newest one that we've done is always the one that's topmost. Okay, so this is the most recent one that we need to look at. So let's run that again to show you. So I'm clearing my screen. Okay, I'm going to do git log online, and that is basically, don't worry mate, I've got your back. This is where you are. This is what you've done in the project. This is the one that you're working on. The head I'm focused on is on the main branch right at the front of it. Okay, so now that we know our ID of the commit that we want to travel back in time to, so we could have chosen any one of these commits, we can now travel back in time. So how do we actually time travel? Well, in the world of Git, if we think of it as like, I want to go back in time and check out what I was doing last Wednesday, the key word in that sentence was checkout. So basically I want to say Git, I want to check out, and then you give it the ID code. So let's do this right now. So if we remember our log, so let's look at this right now. So there is our log. Okay, let's go back to when just the index page was created. So I'm going to be cheeky and just do a Control-C on my keyboard to copy that code. I'm going to say Git, I want to check out last Wednesday, last month, last half hour when I was on Git commit this ID number, and I'm going to hit return. If you get a message like this on your screen, do not panic. All that has happened is that I have been fiddling around with my project since I made the last commit, of which Git itself has said to me, hang on a second, what do I do when you jump back in time? Should I show you the CSS directory or not? Should I delete it from your screen? Now, it's not deleting it from ever in the project, it's just the view. And if you looked very carefully, okay, the newer files have started to disappear. So I'm going to say do you want no for the moment so we can get past this screen. And what's going to happen is it's saying to you, Git is now in a detached head. We've switched back to this view, okay, and you can look around and you can experiment. I'm going to suggest you don't, okay, and if you want to make a new branch and start experimenting, we'll look at that theory later on. But obviously Git is assuming you already know how to do that. But just don't. When you're back in time, just look around. And when you're happy, all right, what I want you to do is we want to Git switch back to the main where we were, okay? And now everything has returned. So what has happened is we jumped back in time. Git was like, I'm a bit confused. What do I do with these other folders? Didn't ask us about all of them for whatever reason. That's fine. We just said, yeah, you can show them or not show them. They're not deleting them from history. It's deleting them from the view temporarily. Little bit confusing. It can cause extreme panic when you do this for the first time. Just remember, everything is always saved if you've been using Git correctly and you've been making those commits regularly before you do anything like this. So we've gone back in time. We're now down here. We've had a nose around, a bit like the ghost of Christmas past. We can see everything, but we are not going to touch anything. We are just observers in the history of our project. And now we are going to switch back. Now, when we came back to the present, we didn't use the word checkout. We used the word switch. And switch does two jobs. It switches branches, which we'll learn about later on. Obviously, we're on the same branch in this example, so that didn't need to happen. But when it does do a git switch command and it executes it, the other part of that command is that it always pushes our focus right back to the very front head of the branch, okay? And that's what it means when it says we are pointing at the head. So we have gone from here. We've switched back to a moment in the past. We've had a look around to whatever it was that we needed to go and look at. And then when we're happy, we've switched back. And the moment we've switched back, we've been put back in this position at the Git head. Okay, so we have literally time traveled, looked around and come back to the present moment in time. Okay, and that is what Git is all about. It allows us to jump forward and back through time to see what we were doing, so we can think to ourselves, why were we doing it that way? Maybe remember something that we've since forgotten, especially on complicated projects. That can happen quite a lot. And we can just remember, okay, the reason that we've got this error is because, I don't know, that new piece of code that we've developed since didn't exist, and whatever the situation is. Okay, and this is really good. This is what version control is about. We can also do that on other projects and code that our teammates are working on. And we can look at their timelines when they've shared files with us, or if we're working on a collaborated project together, they're developing one page, we're developing, and I can look at their history if I know the commit commands, and so on and so forth. So if that person's off and I can see their history, or they're off on long-term sick, for example, I can still see and think to myself, oh, they've done it this way because of this, and I can kind of mentally build up a picture and understand what's going on, not having spoken to them at all. And that's why we have version control systems. So why was it then that Git was telling us, okay, we can look around in the past, and I was saying, but don't change anything. Okay, and the reason being is this. So we're going to look at another branch now. If we jump over to this diagram, what I've done is I've now just shown you what could happen in between the time. So in between this commit we've traveled to and our next one is the timeline that we're looking at. Okay, so let's look at that in a little bit more development. So maybe we've gone back in time and you've realized you've made a mistake, and what you want to do is fix that moment in time then. But if you do so, everything on that timeline is going to get a little bit screwed up that you've done since then. So what we do is we get around that by creating another branch to our timeline. So we've now got two timelines. And it's really important to know that in the world of terminology in version control, we don't actually use the word timeline. Essentially, that is exactly what it is. But we use the word branch, okay? So what we have got here is we've now got two branches. Our default branch is always called main. This is where we want to be when our project is in those really sweet spots. But while we're developing it, because we don't want to upset something that's live, could you imagine the mess that Amazon would get in if every time they wanted to add a new tool or a feature to their website, they fiddled with the live version of their site? No. What they do is they have multiple branches with different developer teams working on different features and tools that they are developing at the same time. And when they are happy with that branch, they merge it back into the main timeline. So what we've got here is if we travelled back in time, or indeed we could, before we move forward in time, create a branch. We then basically, it's like a clone. It's not technically a clone. There are no duplication of files. But if you mentally build an abstract picture in your head about the project being cloned to a second branch, what happens is Git now creates a second arrowhead. Our original still lives in the future, looking after the main branch. But we now have an arrowhead for the second branch. So if we come out to our code, and I do this right now, so let's go back here. So we're back in time. So I'm just going to switch, or we have switched back. Let's do a quick status. It's always good to know where we are before we do anything. Okay, what we're going to do is we are going to now create a new branch. So I'm going to say git, okay, branch, and I'm going to call this, now I number my branches because you will see it helps with the logical flow of where we're at when we get like 20 branches existing. So I'm going to say we haven't got a contact page. Let's create a new page and I'm going to call it contact. Now this is my little naming convention. I've never been shown this in industry. I personally like to operate this way. Instead of new page, what I would normally say is, okay, this is a development, so I put dev, or if it was a bug fix, I would put bug, or bug fix. So I've got a bit of a prompt as to what the page or the branch has been created for. So in this instance, I'm creating a new page called contact, and now I'm going to switch to that branch. Oh. So it's saying, well, it doesn't know where it's going to. So git switch to one-new page contact. Okay, so I've now swapped to the new page. And I can check that. Not only does it tell me there, okay, that I've switched, I can now do a git status. And that will also tell me that I am on a branch called one-new page contact. So I know what the branch is existing for. Okay, and there is nothing to commit because I've not added anything or done anything just yet. Okay, and if I was to run a git log now, even on a one line log, okay, I am now going to see that my head, of which there are 2, are now pointing direct. So I'm on this one first, but the other one still exists as well. And I can create another branch if I want to. I could create Git branch. This time it's branch number 2, and I'm going to create another new page. And this one is going to be called GDPR, because it's a website that I'm building, for example. And I could git switch to the new page as well. So I'm just going to copy and paste because it's quicker. And now it's telling me I've switched to a new branch. Okay, and again, I can run a log, one line, and now it's going to say to me, I now have 3 arrowheads. Mine is pointed to the latest branch that I've switched to, but main, which is more important than the first one, and so on and so on. And it would keep listing them. Okay, so I know where I am at any point in time. And obviously Git status is exactly that as a quick synopsis as well. What I can also do is I can run a list of all the branches in my project. So if I want to know just about branches, I can say Git branch, and it's like saying, okay, this is what, tell me what branches exist. And it's telling me there's a main branch. And this is why I number my branches, so I can see the flow in order, because it's alphanumerical. So that's how we can switch around with our branches. And of course, if we go back to my diagram here, it means that I can start from here, jump back, do some updates, commit them. I'm happy with everything. I've tested everything. My new feature, like maybe I've added a form to the contact page. Everything that I've done is hunky-dory. So let's merge. And then once I've merged, that branch, okay, can still exist for future updates, but it's also had all of its features at that point merged back in. Okay, so now would be a really good point to teach you about merging branches back into the main timeline. But I don't want to do that, because realistically, in the real world, we wouldn't be working just on our local repository. We are now living in 2026, so life has rapidly changed with regards to technology advancements since 2005 and 2008, when all of these tools and techniques were developed. And so generally we work as one unison item, with Git and GitHub as one sort of version control being and godly power that is looking after our project. So I want to teach you the merge process as one command that uses both Git on our local computer and GitHub in the cloud, which means we now need to connect our computers to GitHub and start pushing copies of our project and our local repository and cloning it in the cloud, so that we can pull it down elsewhere. We can come back to it in the future and know that this snapshot is all saved. So we are going to learn how to do merging of branches and deleting anything that we don't want right after the next step, which is now connecting to GitHub. Let's have a quick look here now. So this is basically the blue bit that we are going to be working on. So we understand how to work on a local Git repository using version control systems. Now we're going to extend that knowledge by adding a cloud-based repository system called GitHub to our current process. So we need to have a GitHub account set up. It is free. Once we have the account set up, we need to connect our remote repository that we've created in GitHub to our local repository, so the two can then talk to each other. And then once they can talk to each other, we can push up into the cloud a copy of our local repository at this precise moment in time for safekeeping in the cloud, so that we can jump from computer to computer in different locations. But more importantly, if something was to happen to our computer and we only had that one computer, that we haven't lost all of our work. So that's the backup in the cloud that we really need. And of course, once it's in the cloud, we can work with a team as well without having to send files on attachments to emails and all that jazz. So to do that, you are going to need to open a GitHub account. Okay, so I have, probably here somewhere, this is my GitHub account. Now mine is very complicated because I have all sorts of fingers in all sorts of pies and lots of different repositories. When you create yours, everything that you do is going to be empty, okay? And there is nothing wrong with that whatsoever, okay? And you will come to a home screen. Now it will be a bit like this. Mine is different because there is content in my cloud-based repository, and just like on my local computer, I can be working on lots of different projects at the same time. At the moment, I'm developing 2 different mobile app games because I love mobile app games, and I am building my own blogging website using an MVC system and process. And I've got files and folders going on for demonstration projects for this video and my student classes. So I have my fingers in lots of pies all the time, and you will do too. But if I can work as a free account holder, as a solo developer, so can you. And that's the beauty of GitHub, okay? It is free. So if you're asked to pay for anything, don't. Okay, you do not need to. Second of all, I would strongly suggest, especially if you are under the age of 18, that you go into your profile, find your email address, and there'll be a button where you can toggle it on and off to be public or private. And I always like to keep my controls in that sense private, and so I would suggest you guys do the same as well. The other suggestion that I have when you create your GitHub account is that you do not use a college email address, because when you finish college, that email account stays with the college and you will lose access to it, which means you will then not be able to log in or even use the password recovery system, because the password recovery system will send the email to your your college email account, and you won't be able to access it. So use a Gmail or something like that. And then finally, the last little piece of advice I give you, just in case you decide that you're going for a job interview and your future employer goes, oh, it'd be really nice to see some of the work that you've done in your GitHub, okay, and you need to maybe share the odd file or the odd folder, you don't want to be using a dodgy, rude, embarrassing username, because this is going to be a professional account that you will end up using in your working life. So don't call yourself Miss Fairy unless you're happy to be known by Miss Fairy or something a little bit more explicit. Okay, use a practical name that you're not going to be embarrassed about talking and giving when you give access to your shared folder on GitHub, because you'll be embarrassed otherwise. Okay, so if you're not happy to give that name to a boss, don't use it, basically, is what I'm saying. Okay, the first thing that we are needing to do is we are needing to go and create a new repository. So I've got this project that I'm building with you guys right now. Now, you will only have one space. I have lots of different organizations. I've still got code from my business in here that has closed down and all sorts. So I'm going to click on the right up screen up here. You've got organizations. You might want to create an organization per subject. So you might have a web development class and a software development class, and you might want to organize all the different things you do that way. And so you could click on organizations and create yourself like a subject and think of it as an organization. I've got here my teaching job, which is what I'm going to use right now, because obviously this is a video for my teaching job. And so I can switch the organization, and I know I've changed. Up here, it tells me. If you do not want to use organizations in your main repository in GitHub, you do not have to. I'm just trying to show you a way that you could possibly organize your files and folders. At the moment, I just want you to use it and worry about it later, even if it's too much to learn at the moment. Okay, going back to this screen here, okay, I have got some repositories already existing, but I am going to create a new repository. Now, if you've got none whatsoever, you might have a new repository green button somewhere in the middle of your screen. I'm going to click up here, create new repository, and it's going to tell me who the owner of that is. So the organization is called Teaching Job, and I'm going to call this my test VCS project. Okay, just so that I can delete it later and know what it's about. The name has never been used before, so that's really good. It's giving me a little green, whatever it's called, just a thumbs up. That's great. I'm deliberately not giving it a description at this moment in time. And I am not doing anything else, as in I can choose the visibility to be private or public. Other than making sure that it, as a quick visual check, it's showing that it's a private repository in the cloud, I'm not doing anything else but clicking on the green button. And now my repository exists, but it is empty. Now what what GitHub is trying to do is saying to me, okay, you've created it in the cloud, now you need to connect it to your local repository on your computer. And it's tried to be helpful by giving us some starter information and advice here. So for the moment, I'm going to say ignore this, but for those of you who are a little bit more vigilant, you will see that actually we've used most of these commands at some point already. The ones that we haven't used are mostly these ones here, and we're going to use them now. So what we have to do is, now that it exists in the cloud, so we've got our cloud repository and we have got our local repository, but the two of them are not yet linked together. So that linking process is what we have to do, because again, we can have different folders in the cloud, different folders on our computer, and the two need to understand which one they are working with. Okay, so what we're going to do is we're going to jump back to Visual Studio. Okay, I'm going to clear my screen so it's nice and easy for us to see where we are. As always, before I do anything, I'm doing a quick git status. Okay, I'm on branch 2, nothing to commit, everything is clean. Now, just for sanity purposes, I am going to switch back to my main branch because I like to be at the top of wherever I am before I do anything that's different. Okay, so git status, I'm on the main branch, which is good. There's nothing to commit, my working tree is clean. So I'm really happy, and I'm going to clear my screen so I've got some space to work. I'm going to make it just a little bit smaller as well so that I can get everything of my next command onto the one line without it wrapping around on the screen. Okay, so we are all good. So if we look back in GitHub, let's make this screen bigger as well so we can see what's going on. We have this line of command over here, and it's saying we are going to connect a remote repository by adding, and then we're going to call it origin. And we're going to give it that path. Now, if you look carefully, that path is what we are being told here. Okay, so with words that we need, so I'm actually just going to make my life easy, and I'm going to copy that whole line, Control C on my keyboard. I'm going to come back to Visual Studio, and I'm going to right click, and I haven't yet hit the enter or the return key, because I want you to understand one key thing, and that's this word origin. This here as a path, if we have to type that out 90 times in an hour, we are likely to make mistakes. We are likely to get it wrong, and we are likely to confuse ourselves. Plus, we are likely to forget some of it, and it's a very irritating thing to multiply the use of time and time and time and time and time again. So wouldn't it be nicer if we could just type one small easy word to make our lives easier? Oh, I know. Why don't we use the word origin, because that's where it is. It's originating from the cloud at this location. So now what we have is a git command that says git, we are going to add a remote repository. There's the add and the remote. The remote comes first because that's the primary thing that we're going to do. So the first most important command is git. We're going to connect to a remote repository. We're going to add it in. We're going to store the path to this in the word origin, but this is the path. And now I'm going to hit return on my computer. Doesn't look like anything has happened. We can do another git status just to check, but again, it doesn't really tell us anything apart from our local repository. Okay, so let's go back now and see what else it asked us to do. And it's saying, oh, okay, we need to push a copy upstream. That's what the -u means. I always think of it as upstream to origin. And we're going to call that branch main, because that's what our local branch is called, main, right now. Okay, so coming back to Visual Studio, remember our diagram, we are in the green. Okay, we are right here, right now in our local repository, writing a git push command. So that command again is git push upstream, so it's going up into the cloud to the origin called main. Okay, so let's do that. I'm going to copy to make it quick and easy. I'm going to come back to Visual Studio. There is my command. I'm going to hit return. We're going to give it a moment because it's obviously going through the internet, and now there's a lot more stuff being reported back to us. So let's look what this says. Okay. It is telling us we're on branch main on our local computer. Oh, so that's the status. So it is telling us, so there's our command. Enumerating objects. So in our entire project, it's considered 16 different things. Don't forget that's also knowledge of all the commits that have taken place, not just the actual files and folders, okay? It's counting the objects, so it's got all 16 of 16 known. All right, it's going to compress it. We don't need to worry too much, but obviously that information's got to transfer over the internet, so it's making it quicker and easy to do so, okay? And it's telling us how it's compressed it and everything's done. So again, we don't really need to look at that too often. And then it's going to write this 16 of the 16 objects in the cloud. So we know that that's been done. And it's actually telling us how many megabytes in seconds as well that took about. So that's kilobytes and megabytes per second that it did this over. Okay, which is all good. Just information, really. We don't really need to know anything or do anything with it. But total of 16 things was done. Okay, resolving deltas. I don't know what that means, but we don't really need to. We just need to make sure that we're all happy. And this is interesting. So it's now talking about the remote repository. And it confirms to us where the remote repository lives. So we know the address to that remote repository. And it is confirming that it created a new branch in the repository in the cloud. And it's called it main. So our local main has traveled from our computer to a new branch also called main. So we've kept the names the same, okay? That is so that we cloned our local repository into the cloud, and that we in our heads know that they are clones now, okay? Branch main is set up to track the origin main. So everything we do on branch main on our local computer is now tracking and comparing its knowledge to whatever the origin main branch is going to do. So again, this can be quite confusing because the whole concept that we are learning right now is an abstract thing. We can't physically see that connection, but we are being told that that connection exists. So in our heads, we have to imagine a mental picture of like a string from the ground where our local computer lives to the cloud in the sky above us where our origin main exists. And now there's like this thread, this branch of, I don't want to use the word branch again, but this like, there is a relationship, a connection, like a silver string connecting the two from the cloud and the ground together, okay? Now, it is possible that as we now develop on the ground, our project on the ground becomes more advanced than the copy up in the cloud. So we have to regularly, when we do a commit, actually do a third line. So what we do is we git add to the staging area on our local computer to tell Git about all the files that we want to deal with right now, whether that's just one or two files that have changed or the entire project. We then commit them to our history book. So our local commit, our local repository has been updated with a commit. And then we just do a quick push up to the cloud. So when we're on our computer over here, that line here, git push upstream to origin main, is what we then learn as a third step in that process, okay? So we git add, git commit, git push upstream to the cloud, okay? So when we are working, whenever we are doing anything in the world of development and we feel like we need to make a commit, we now do 3 commands: git add, git commit to our local repository, and then clone a copy of that up in the cloud into the branch given the same name. Okay, and that's all we're doing. We're just working on our local computer. We can time travel on our local computer. Okay, we can do whatever we want by creating new branches, doing more development, but any action we take like that, we can just go push it up into the cloud or pull down the latest copy. Okay, now we haven't learned about the pull down, but you've got starting to build a theory now of how we push and pull from the cloud local copies of our computer or onto our computer. Okay, so what I do is if I did git branch like we did earlier on, my local repository talks to me only about my local branches that it knows about. Okay, but if I was to change that command, remember that's what a flag command does, and I use the word all again that we've already been familiar with, it now shows me another line. And this time it's saying, okay, on my local computer, I have 3 branches. We are on the main branch, which is shown in green with the asterisk, and we have these other 2 branches, but our remote branch only knows about 1 branch, okay? And that is why it's shown in red. So there is still a little bit of a mismatch, okay? So what we could do is we could go git switch on our local computer to our new branch. So I'm going to copy it and I'm going to paste it. Now we can see that we've switched branches on our local computer, and I could this time git push. Hang on, let's go through the whole process. So git add. So in this case, because it's the first time I'm adding this branch to the cloud, I'm going to do a git add all. Okay, git commit again, message all of second branch content added. And I'm going to now git push upstream to my origin. And this time I'm going to use the same branch name. So remember, we're trying to clone everything that's happening on our local computer. Now I'm going to have a second branch in my GitHub. Again, it tells me how it's updated, what it's done, it's checked everything out, it's created a new branch, and now this local branch of mine is set up to track what's going on in the origin in the cloud. So now, if we just quickly, before I do the third one, go back to GitHub, okay, and I come out of here, and let's just say I refresh this screen, you can see that now that there are things that exist, it's updated. And what it's telling me is I'm currently looking at the main branch, but it is telling me how to find the other branches. It's also numbering those branches for me. So it's saying, do you know that there are 2 branches? Let me make it a bit smaller. There you go. It's telling me 2 branches exist. Okay. I could also delete them from the cloud, but we haven't learned how to use GitHub yet. So we're not going to touch anything there. Okay. But I can now go in and explore. So I can go into my main branch. I will see all the files in the folders. Okay. I can click on this. It will give me the path. I can also download my entire project as a zip file. Okay. All right. I can work inside GitHub. So if I was on another computer right now, let me just get rid of this. Okay. And I've gone, okay, let me close this folder. And I open my computer, okay, I can now clone, knowing that command there. So I've done work in the office, I'm now gone home for the day. I can copy my path, okay, I can come back in here and I can clone, I can right click, oops, there we go, I can paste it in. And I can hit return. I'm not going to do it because it's the same name, but obviously. And then I can start cloning, and that's how I can start moving around. While things will change on my local computer, but whenever I finish work, it's important before I turn off for the day, whether it's at college, office or home, I just push it into the cloud. And as long as I know my user logon details for my GitHub cloud, I could be in Australia 1 minute, travel over to China for the next minute, back to America, and come here and still access the exact same files as long as I've got that internet connection and log on details. And that's how we start moving around. So what we've done now is we've actually started to work not just as a local developer or solo developer on one machine. What we've actually started to do is we've started to operate and understand now that this is how we can clone a copy of our computer or our projects. And of course, we haven't got into the whole git pull command yet. You generally, if you work the way I've taught you so far, you won't ever really need to pull down, but you will have enough working knowledge now to understand where you are, what you're doing, why you're doing it, and so on. What isn't covered in this video is then how you connect to teammates, okay? Once you've got your local repository, what you then would do is switch a button or features inside GitHub to turn that into more of like a shared environment where you can connect to a team repository and so on and so forth. But that is a lesson for another day. Okay, so now that we know how to connect to GitHub and we are pushing copies and cloning our local repository and putting a copy of it up in the cloud, how do we now merge all of these different branches that we've been developing different features of our website on, or our software programs, and how do we bring everything back together? So what we're going to do is we're jumping over to the left-hand monitor where I can show you a diagram of physically the abstractness of what our project status is in. Remember, everything that we do, we cannot see it. We have to build these mental pictures, and to help you, I have done these diagrams. So we started off with a main branch, okay, but we never develop on a main branch, which you now know since we've started this video. We always create a separate branch to do the development work on. So I have created two branches. On this first one, I have developed the contact page, and I have saved it and pushed a copy of my site up into GitHub with regards to this branch. I have then created another branch, switched over to that new branch. This one is for the GDPR, like the privacy policy, the terms and conditions for my website. Okay, and I've created that. Everything on this second branch knows nothing about the contact page on the first branch. So it could be like I have done two different people working on this project, and the first and the second branch do not know about the other one's features, okay, which is how development in projects with regards to teammates would work. And of course, the main branch at the moment doesn't know about any of the other features. So we now need to bring together everything into the main branch, okay, and bring our project together and unify it. Okay, so that's the theory. So how does it work in practice? So if I minimize this screen, here is my site at the moment. So let's do a quick Git status to work out where we are. And we are on the main branch, okay, and it is up to date with the origin main. So at the moment, my main branch is empty of the other features that we have created on branch 1 and branch 2. And I am being told that the cloud remote repository in GitHub and the one on my local computer are the same. So everything in this project at the moment, as far as the main branch is concerned, is hunky-dory, for want of a technical term. So what I'm going to do, and you won't necessarily have to check out other branches, but because of the way I've developed my site in order to show and demonstrate this to you, I'm not going to switch. I'm going to check out from the cloud my other branches so that you can see what's going on. And what I want you to do is look and keep your eyes focused on this list of in the Windows Explorer pane here of my site. So let's go to Git, check out. Okay, I'm going to branch, new page. Okay, and this is my contact. So this is where I've developed my contact page. And if I hit return, the site is now showing me that a contact page exists. I can click on it, I can see it, and I can go view it and all that other jazz. The terminal window has reported to me that I am, where are we? Down here, sorry, my bad. We have now switched over, even though we checked out, and I'll explain that in a moment. But now that we have switched over to the other branch called 1, new page, contact, okay, and it's telling me my branch is up to date also with what I've stored in the cloud. So as far as this branch is concerned, it is hunky-dory. We are going to push the up arrow on my keyboard so I can cheat, and I'm now going to check out whatever it is that I've been doing on the other branch, which is called GDPR. Now, if you haven't learned about GDPR yet, it is about the UK and Europe have to put notices on a website to explain how they handle your private data if you enter information onto a form or click anything. So you have to have a privacy policy, and that privacy policy is called GDPR. So naturally, I want to create a GDPR page. So I'm going to hit return. And again, if you've looked now, the contact page has disappeared because that's on a different branch. And this branch, and in fact, if you can see up here, because it was still open, Git has actually said, well, this page doesn't exist in this branch, so I'm going to close that not to confuse you. But the GDPR page now exists. So if we come back to our little my little diagram here in Photoshop, okay, when we was looking on this first branch, which was the contact form, this branch was only concerned with the files and folders it knew about. nothing else in the project. Then we've moved to the second branch, and the second branch is only concerned with its features and files that it knows about, which was the GDPR page. But these two pages don't know about each other, and at the moment main is very severely behind both of them. Okay, so we're at a point where everything's been tested, we're really happy as our developer process, and what we want to do now is we want to start merging everything back into main without losing our contact page, without losing our GDPR page, and without upsetting anything that is already existing in our main timeline. Okay, so this is what we're going to do now for the rest of this part of this process. Okay, so now that you've seen what we want to do and you've seen the status of our local repository, let's just quickly dive on over to GitHub and see what's going on there. So I've navigated my way through to this project, so I'm looking at it, and at the moment in the window below here we are looking at the main timeline. Okay, and it can tell me that I've got 3 branches, and because I've literally just seconds before creating this video pushed a copy of both of my 2 new features and my 2 new branches up into the cloud, it's showing me a quick synopsis because that's just changed. Okay, so what we can do here is we can go to our branches, and I can see now that I have 2 new branches that are existing, so clones of my local repository, which we just checked out and looked at. So we're all good. So what I'm going to do is I'm going to git checkout main. Now everything is going to change because remember, our main branch is completely behind everything else. Okay, so those pages now have now disappeared, but we do know that they exist on the other branches. Okay, we need to merge everything back in. So git status, just to clarify, we are on the main branch. Before we do anything, we're on the main branch, everything's up to date with the cloud version, and we know that both the local and the remote repositories, the 2 of them, even though they're cloned, they are severely behind everything else. So I'm going to clear my screen to make it nice and easy to follow. We are going to merge in the first branch. So I am going to git merge branch 1, which is called new page. Make sure my spellings and capitalization is perfect. I'm going to hit return. Okay, it's telling me the 2 commits that it knows of. It's updating the old one to become part of the new one. The fast forward is that the fact that obviously the main branch has now had to speed forward through time to catch up to the latest commit. So that's what the fast forward, that's kind of like the mental picture. So if we come back out here to my diagram, okay, so our first branch is over here. Okay, and the main one before we did the merge was there, and it's had to fast forward. So these 2 now, this commit right here has actually merged into this timeline. So if I was to update this actual diagram, there would be a blob just here. Okay, and it's told me that 1 file had changed and it's all happy, so we could do a git status, make sure we know where we are. We're on the main branch. My main branch is now ahead by 3 commits because it's added everything together. So we need to push it up into the cloud. So before we do that, let's refresh this page. Okay, and we can take a look at main. So at the moment, this is what GitHub knows about our site, and there is no contact page at the moment. All right, so this is a way of double checking everything that's going on, and you can keep an eye. Okay, so we are going to minimize that. Okay, now we've got to push a copy because our local repository is now ahead on the main branch than the cloud. Okay, so we are going to git push upstream to origin, and it's going to the main branch because we now have merged them together, and on our local computer we need to update the cloud. So I'm going to wait. Git's going to do its thing, and it's now telling me that it's merged the local. It is now telling me that it has updated the main branch in the cloud to be symmetrical or a cloned version of what's going on our local repository. So if we come back out to the cloud, okay, and all I'm going to do is refresh this page. Okay, now you can see that the contact page exists in our main branch and the cloned version of our site on the cloud and the remote repository knows about it. So this is a really good place to be. My branch still exists, so I could technically carry on developing and adding more stuff to that branch, but we're not. We're done with it. We are going to delete it in a minute, but I'm going to show you the deletion process in a second. So let's minimize this back down, okay? And this time we are going to do a git status. We always make sure before we do anything we know where we are. We are good. So I'm going to clear the page. Now we're going to git merge in our second branch page, which was the GDPR. Okay, so here we are in GitHub. Here is our main site, our main branch with the contact, but no GDPR page. Our branches still exist because we haven't deleted them, but we are now going to merge the feature of this page being existing now into our main site. So this is how you would develop a site that's already gone live to another client. So we're going to minimize. I'm going to hit return. So the merge process has finished, okay, and we can do a git status. All right, so we're on the main branch. The branch is now ahead, obviously, because we've now got, so we've now, if we go back to our diagram, the features that existed in this commit have now been pushed up, and so there is now a commit existing on this line. The reason we got a different message is because this one isn't a fast forward, because we could have actually, as far as time dates go, finished developing this before we'd done the contact page. Even though the orders, you know, we jump about in projects, we don't necessarily work in a really linear fashion, and we don't sort of start our day going, we're going to do all of this in a nice, you know, ideal world. What we have is people talking to us, our managers coming and giving us different commands and saying, can you just go and look at whatever's gone on that page, and we fix something and we've jumped back. And so actually when we merged the second branch, time-wise, it was actually done before the other branch in physical time, but as we've merged them back in, it couldn't do a fast forward because technically it would have gone, the time and date was behind, so it had to do a different style of merge. Now you don't need to worry at this level what type of merge takes place. We've seen the fast forward merge, and we had an alt strategy merge, and that's fine. It took me a second there to get my bearings because it's been a while since I've seen that happen as well, but it's fine as long as the end result is that everything is merged. We don't really need to see under the hood of the car and work out why Git merged the way it did or which strategy at this stage in our knowledge, as long as the outcome is what we want. So let's go and see if the outcome is what we want. So we're doing a git status, okay, and we are here on the main branch. We know everything is ahead, that's absolutely fine. So we do need to push it up into the cloud. So we're going to do git push upstream because it's going up into the cloud, into our origin, and we're also going to update the main branch in the cloud, okay? So I'm going to wait a second while it does its thing. It's going to report back to me what has happened. It's made 4 different changes. Everything 4 of 4 is done and completed. It compressed some of it because of the data transfer. Everything is good. It hasn't dealt with any problems, and it's told me the 2 different commit numbers that from my local PC and my origin PC, which is the cloud. Everything is happy. We can do a git status, and we are now back to a point in our project where our working tree is clean. So before we do any deletion of branches that we don't want, let's come back over here. Let's go into our main branch, and now that we've loaded it, you can see that it has joined in our GDPR. So we are now in a point on this timeline that everything in this location is now just perfect. The separate features that we had designed in different timelines have been successfully merged. The first timeline was done via a fast forward, and that's fine because this was so far behind it had to speed through his, you know, times and dates to catch up here. But this one was in a different location, and although I've got the diagram for it being in front, technically it was behind, and what has happened, it's done a different type of merge, which is why it threw me for a second there. But all is good, and we are now here. So technically we don't need these branches anymore, and we have to remember that at the moment GitHub has this like line of communication stretching between our local computer on every branch and its corresponding branch up in the cloud. So we've got the connections to handle, and we have the branches to delete in both the cloud and the local. So we bring everything in our project back to one nice, neat milestone. And that's how we would tidy up a project when we are ready then to publish it live. So we've got no trailing branches, or, you know, we're in a really happy status, and we tidy up our project, especially if we're not going to touch it for about 6 months or so, which happens with my clients. My clients will come to me, say in January, say I need another 3 or 4 pages, or this tool or this feature adding to my site. I'll develop it, and then I know I am not going to develop that site or touch it again until my client next comes to me in another 8-9 months and goes, right, I now need to add some more pages. So this is how I manage my working environments, because I know, I mean, sometimes I can't remember what I had for breakfast, let alone what I did 9 months ago on a project. So this is how I keep myself organized and stress-free for managing all these different projects using version control systems. So let's go back over here. Okay, let's get rid of this picture, and we are in a happy place in the cloud. We are in a happy place on our local based machine, so everything is good. Now let's do a quick git branch all command, okay, because it's going to list me everything. So we are on the main branch, which is good, but we have 2 remote branches that we don't want anymore. We have 2 local branches that we don't want anymore, and we'll need to learn about pruning the connections between these branches on the local and the remote repositories, because the connections themselves are something that Git is also having to manage. Now, we can delete branches in the cloud 2 ways, okay? GitHub actually provides us lots of tools. So if we go to branches, okay, and let's go, we're going to delete one of them using GitHub, and the other one we'll use a command in our local computer terminal window. So if you look over here, I can delete the branch. Okay, so let's see what happens. I'm going to delete the cloud version. Okay, I can refresh the screen. It has gone. So we now know that branch 1 in the cloud has been deleted, but on our computer down here, okay, so we have deleted this branch in the cloud. If I run that command again, okay, it doesn't know. Our local computer hasn't had any kind of communication from the remote repository. Our local repository still thinks that branch in the cloud exists. So we have to update Git. Okay, so this is why when you learn how to use these tools, I would prefer you not to delete things in the cloud. I would like you to learn how to do it what I call the proper way, by giving commands to Git through your local terminal window. Let's now delete that one branch using our computer. So we're going to type the words git to give Git command. Okay, we are going to delete the branch on our local computer, first of all, called one new page contact. Okay, so now we're going to have deleted the branch in the cloud, the branch on our computer, but don't forget the connection still exists. So hit return. Okay, the branch was deleted and it's telling me there when that action is. Now let's just quickly update. So you can see our local computer has deleted the branch contact, but it still thinks the one in the cloud exists. Okay, so what we're actually looking at here now, because we know in GitHub we've deleted it, what we're looking at now is still the connection. So we need to prune that connection. So cut the cord between that Git is managing between what was the local branch and the remote cloned version of our branch. Okay, the connection still exists and it's wrong. Okay, so to do that we use a pruning command. So what we're going to do is we're going to give Git a command, And this time it's like a fetch command. We haven't encountered that just yet, but we are going to give it a flag called prune. Okay, we won't necessarily get too much into the whole fetch at the moment, but when you prune, it's all or nothing. Okay, so we're going to prune everything that we don't want. Okay, Git is now telling me that it's now got rid of the connection between our local repository and our cloud-based repository, because we know that the branch doesn't exist in either location. And if we do a branch all now, you can see here that the name of that branch has gone. So this one still exists, okay? And all it's saying is that it didn't know where now to look and focus. So it's just showing that the origin and main and the head, it's focusing on this branch, which is fine, okay? So let's just do a git status and swap. Git status, we're on the main branch, everything is clean, okay? So what we are going to do now is we're going to delete from here the branch in the cloud. So let's just make sure that everything in the cloud is up to date. So we're going to refresh. So we are going to do git push a command to the origin of our repository. We're going to do a full delete flag, and this time I'm going to name the page or the branch, and it was the GDPR branch that we were on, and I'm going to wait for it to give it itself to think. And it's now telling me that in GitHub, in my repository called teaching job or the organization, because remember I've got lots of things going on, in this particular repository we have now deleted the branch called new page GDPR. Okay, so let's go and have a look back over there and see what's going on. So if I refresh this page now, it disappears. So that is how we can delete it. Now, because I have deleted it from within Git, if I understand rightly, git branch all, okay, it has also removed the connection, which makes life a lot easier. So I'm just going to do a git fetch just to make sure that there is no trailing problems or connections that shouldn't exist. Everything is now looks like it's been fine. We can do a git status. Okay, we're on the main branch. Your branch is up to date with origin main, and what I can do is I can check out main just to make sure that my local one is definitely working exactly, and it is. It's telling me what I've checked out from the cloud from the branch main is exactly the one that I've got on my computer. So I know, peace of mind now, that everything between my local repository and my cloud-based repository are singing the same tune, as it were. Okay, we know that the connections between the remotes and the local branches also got pruned and deleted along with the branches that don't want to exist. And if I do a git branch all now, okay, there we are. We are now on the main branch, and that's just basically saying connections exist between it and we're absolutely fine. Okay, so my project is now fully up to speed. We have learned how to delete manually using GitHub, but when that happens, we leave behind the connection known by Git between our local and remote repository. So it gives us a second job to do, which is why I don't want you guys deleting things manually in GitHub, and why the best way to do it, to say, you know, you want to do a job once, not twice, is to actually delete a branch from inside our local terminal window, so that when it deletes that way, because we're in control of everything going on, because Git's on our computer, it's going, okay, well, we're going to delete the connection to the cloud along with the branch in the cloud, and it does two jobs in one. So that kind of brings us full circle, and that now is the end of this lesson. Now, okay, so I know there was a lot of information in this video, and it was a very long video, probably one of the longest ones I've ever done, but I wanted to go slowly, deliberately, to make sure that you understood what was going on. And in full transparency, you've only just started to scratch the surface of the tools and functionalities and features and assistance that Git can give you, especially when it's paired with GitHub in the cloud, okay? But as solo developers and young fledgling developers, what you have now is a really, really strong foundational knowledge of understanding that there are connections that Git looks after between the cloud and the branches that exist on our local computer and the cloned versions. It knows that you have to prune them. You know how to create branches, merge branches, delete branches, how branches are different timelines, how you can commit different snapshots of your project at different moments in time, and how you need to give those moments in time a specific message so that when you track back through the history logs, you can see a meaningful description that explains to you what you've done, why you've done it at that stage, and then you can check out in the history of your project what you were doing, a bit like the Ghost of Christmas Past, having a good old nose around. And you've then got a choice. You can either create a branch in the past and then create a separate timeline by which to then start developing from that moment, or you can jump back to this present day and age and then you can carry on creating branches that way. But you remember that in an ideal project management scenario, you never actually truly develop anything on the main timeline or the main branch, because that's why the feature of branches was developed, so that you could use it safely to experiment and develop. But I am going to strongly suggest to you that you try to learn to work with branches and merging features back in and get familiar with this process, because it's going to give you a lot of power to explain and talk about this in job interviews, and that will knock spots off your competition from people who don't have this skill and knowledge, because you'll show you that you've got a far superior understanding, and it will just genuinely make your life so much easier as a developer when you know what's going on, why it's going on, and how and why you've worked the way you have. And if you ever do leave a project that you know you're not going to touch for another couple of months, and you need to leave it in a nice, happy, tidy state, try and merge any of the branches that you aren't going to need when you come back to the project. Just try and tidy your project up as much as possible before you leave it for a period of time, because it will help you understand a nice, clean, blank canvas to start working on again when you're ready to pick it up. So that's everything from me today. And if you have watched this video all the way through, thank you so much. Please be sweet, do hit the subscribe button. I promise my future videos are not going to be so lengthy, but I did need to get this skill out there for the support of my students, and I hope you've gained something from it as well. So thank you very much for watching, and I'll see you on another video real soon.